going to be looking at this problem solving page today. This is one of those tough ones. I really want you to just follow along, get these examples in your book so that when we take our M skills, kind of the end of block test, we are able to do these types of problems with examples because it will be asked of you on that M skills, and I don't want to leave you kind of high and dry. So I know this isn't going to be the most fun of assignments, but I think that it is one that we need to take a little bit of time on. Everything is going to be on the video, so make sure you're just following along. And when you're done with the video, you just need to give yourself time to work on anything that might be missing in class. So what we're asked to do in this problem solving is we need to find a rule for these problems. So when you are in math, you have inputs and outputs, okay? So your input is here, and I manipulate it with multiplication, addition, subtraction, and then I get an output. So you see in this example that's already been worked out for us, I started with 5/10, and I ended with 1 and 5/10. Well, how did I get there? Well, it's pretty obvious looking at all these inputs that 1 was added to the output. And you can see in the problem 1 was added. But how did you go from 5/10 to 5/100? Well, think about it. When you have 5/10, I'm going to write this right down here. When you have 5/10 times 1/10, 5 times 1 is 5, and 10 times 10 is 100. 5/100. So they multiplied by 1/10 to move it a place value over. So then they could say that the rule was that you take the input, you multiply it by 1/10. When you get that answer, you add 1 to it. But we don't always say input. In math, we like to make things fast and easy. So rather than say the word input, write that input word every time. We use a variable. So n times 1/10 plus 1 is our rule. And we're going to do both of those. So then you can see here that I can take that rule and I can keep working it out even when I don't have anything in the output. I can find that output. So even with 8/10, if I take it times 1/10, that's 8/100. I add 1, I get 1 and 8/100. So that rule still applies. I can even input 100 with those rules, and I would get an output of 11. And we'll do that here, and it's a couple examples that we do. So the first one is number 1. So now grab your pencil, and we're going to work this out together. So let's take a look at these inputs. So I'm starting with input 1/10, and I do something to it in here, and it equals 3/10. Well, don't write quite yet, but this is going to be a little bit of trial and error. I can take 1/10 and I can add 2/10 to it. That gives me 3/10. But it's got to work on every single problem. So I can take 2/10 and add another 2/10 to it like I did here above it. But that equals 4/10, not 5/10. So we can't just add 2/10 to it. Now I noticed in the first problem I had to multiply and add. So maybe I need to do something similar. So let me think to myself. If I multiply something times 1/10 that I can get close to 3/10 to, well, I can multiply it times 3. 1/10 times 3/10 is 3/10. Let's see if that's hold true. If I make 2/10 times 3, that's 6/10. Not what I have for my output here. So that one doesn't work either. So I'm not going to do that one either. So I'm going to come back maybe I need to think about multiplying by something a little less than 3/10 and then adding something to it. So what if I multiply it by 2? So if I take 1/10 times 2, well, I get 2/10. Ooh, I'm close to 3/10. What would I have to add to that 2/10 to get to 3/10? I could add a 1/10. So I think that's what I'm going to do. 2/10 plus 1/10 is 3/10. Let's see if this holds true. Okay, at 2/10, I'm going to multiply it times 2. Well, 2/10 times 2 would be 4/10. If I add 1/10, 4/10 plus 1/10, 5/10. Seems pretty good to me. I'm going to keep going. 3/10 times 2 would be 6/10. 6/10 plus 1/10 is 7/10. Okay, I feel really good about this. I'm going to keep filling in this chart. Why don't you too? 4/10 times 2 is 8/10 plus 1/10 equals 9/10, and 5/10 times 2 equals 10/10, which is the same thing as 1, plus another 1/10. That sure is 1 and 1/10. All right, I think we got our rule. So our output, how we got this right column, is to take the input times 2 first. So I'm going to put that in parentheses because I got to do that first. And then I need to add a 10th to it. So this is our rule. Now I'm going to do that same rule with a variable. Mathematicians are lazy, so we always want to have something that takes away having to write this whole word. So I'm going to say my output is equal to n for input, times 2 plus 1/10. So now I'm going to take that rule and I'm going to see that it works with that word in my top chart. So I'm going to come down to step 3, and this one, this one, this one, this one, and this one were all up above, but one wasn't, and I don't have an output. So I'm going to use this new rule, n times 2, get the answer, plus 1/10 to find my answers here. So I'm going to take 1, my input, times 2, plus 1/10. Well, what is 1 times 2? That's 2. 2 plus 1/10 is 2 and 1/10. So there's my answer. I can do that with the number 2 as well. I can take 2 times 2 and then add 1/10 to it. And I'm forgetting to put my parentheses around things. Well, 2 times 2 is 4. 4 plus another 1/10 is 4 and 1/10. Okay, that's pretty cool. But what if I skipped a ton of numbers? So this is asking me to apply it to 100 as my input. So I'm going to have to find some room to work here. So over here, I'm going to say, okay, if I put in 100, 100 times 2, and then I add a 1/10, what do I get? Well, 100 times 2 is 200. 200 plus 1/10 would be 200 and 1/10. So I can use this rule to find an answer to anything for an input. If you need to pause or rewind to make sure you have all that, please do. And when you're ready, move on to question number 2. All right, so question number 2, we need to first find the rule. So somehow I have 1/10 and I go to 3 and 2/10. Well, then 2/10, I go up to 3/10. And I have, or sorry, 3 whole. Well, it looks like at some point they added 1 to, or 3 to everything. So I have a feeling somewhere in my equation, I'm going to have to add 3. And we typically add at the end. So I'm going to put add 3 at the end. But now I have to figure out how I got from 1/10 to 2/100. This makes me think of that first problem at the beginning. So I'm going to kind of creep back here. On this problem, we went from 5/10 to 5/100. And I had to multiply it by something in the tens place. So a tenth times a tenth gets me to hundredths. So I think that might be what I need to do here. However, this goes from 1/10 to 2/100. So I'm thinking I have to take my 1/10. Well, what times 1 equals 2? 2. Anything times 1 equals itself, so it's got to be a 2. So I'm going to take 1/10 times 2/10, and then I'm going to add 3 to it. Well, I didn't leave myself enough room on this one, so I'm going to have to erase a little bit so to see if this is true. So 1/10 times 2/10 would be 2/100, because a tenth times a tenth puts me in the hundredths place, plus 3. 3 plus 2/100 is 3 2/100. Seems true. So let's keep going. I'll write smaller this time. 2/10 times 2/10. Well, 2 times 2 is 4. 1/10 times 1/10 is 100. So this would be 4/100. 4/100 plus a whole 3, 3 4/100. 3/10 times 2/10. Well, that equals 6/100 plus 3, 3 6/100. 4/10 times 2/10. 4 times 2 is 8. I know I'm going to be in the hundredths place, so that's 8/100 plus 3. Sure does equal 3 8/100. And finally, 5/10 times 2/10. Well, that equals 10/100. And then I add 3, 3 10/100. I feel pretty good with my rule. It worked every single time. So my rule must be the output is equal to the input times 2/10 plus 3. But to make it easier, n times 2/10, find that answer, add 3 to it. Well, let's keep going then. I found all these, and then it jumps from 5/10 to 8/10. See how our rule works. So I take 8/10 times 2/10. Then I'm going to add 3. Well, 8/10 times 2/10. Well, 8 times 2 is 16, so that must be 16/100. Plus 3 would be 3 16/100. If I plug in 1 times 2/10, 1 times 2 is 2, and that would be in the tenths place because this is a whole 1, plus 3, so I'd have 3 2/10. And finally, I want to try it in this problem with the 100. So I'm going to work over on the side again. So 100 times 2/10 plus 3. Well, 2/10 of 100, well, 100 tenths would be 10. And then I'm going to take it times 2/10. That's 20. And then I add 3. My answer is going to be 23. Pretty cool. So that's how that works. I honestly think this is probably some good examples for you to try. Don't forget, pause, rewind, do this right. But I think we got the gist of it, so we don't necessarily need to do a whole bunch more. But I want you to make sure that you kind of understand. If you're not sure, write down some questions. I will be back tomorrow to help. Then